Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman. Hey, Ben, how are you?
Hey Simon, hey fellow Econauts, how's it going? Today we want to talk about challenges to live on Mars.
All right, Ben, let's have a little refresher about the challenges we face when we want to establish a colony on Mars.
So we already talked about the environmental challenges, but there are more. There are also technical challenges, there are psychological and social challenges, and also economical challenges, and probably many, many more.
I can imagine that some of the technical challenges we are discussing today will respond to the environmental challenges we talked about last time.
That is correct, especially when we talk about habitat design and construction. Obviously, where do we build on Mars? So obviously, everything we bring and build there has to respond to the environmental challenges we talked about last time.
Okay, then let's start with the habitat design on construction.
First of all, we have obviously the requirements for the habitats is because of the thin atmosphere and the pressure, we need to pressurize our habitats. And that means also that the habitats need to be airtight. They need inside in the inside, we need to maintain Earth-like atmospheric pressure and support human life. Then we need to build in a way that we can shield from radiation, because we mentioned in the in the environment challenges that there are obviously high radiation exposure on the surface, or we have to find a place like lava tubes where we can build. And the habitats need to be able to be thermally regulated because of the big big temperature changes on Mars. The habitats need to be able to maintain a cozy, let's say 25 degrees inside, so people people feel nice when they go to bed and everything.
And what about the construction methods?
First of all, we need to transport material to Mars if we don't have the material available on Mars. So therefore, this is definitely a technical challenge, which we will address with later points in more detail. Then, because if we can, we would like to use material we can find on Mars. It's called ISRU, in situ resource utilization. And that means you might find material and resources on the Mars surface, which we can use to actually, maybe build bricks from the Mars soil and stuff like that. And the last thing, because first of all, we don't have many humans when we start off. So initially I don't know how many people might be there, maybe 10 people or 20 people or something like that to start off building a habitat. So the first pioneers, more or less, and they will probably have support from autonomous robotic systems. And these systems obviously come with their own technical challenges. We face challenges such as in general AI. We need to build the robots. They have to be robust and so on.
So after we have built our cozy home, maybe we also should talk about the life support system necessary to survive.
As you can imagine, also the life support systems are responding directly to the environmental challenges, but also are pretty much true for many different space missions as well. So obviously, we are humans. For life support, we need air. That's the first thing we have to take care of. So therefore, we need a technical device that can produce oxygen, either split the CO2 which we exhale and then make oxygen out of it, or we need water and we can split the water, make oxygen out of it, or we have to extract the small amounts of the atmosphere on Mars to make oxygen. And also we need to remove CO2 from the habitat's atmosphere. When we exhale CO2, we need to maintain a small amount of CO2. And if you can imagine, we live in a small compartment, which you might not be able to open the windows. Obviously, it's airtight. So yeah, we have to be able to also to maintain a certain level of CO2 in the air so that we don't get a headache. The next thing, although it's also related to making oxygen, because we can use water to make oxygen, but we need also water in its pure form. So we need to find a source of water, or we need to bring lots of water with us, which then brings its own challenges because water is quite heavy. And, that happens on the ISS as well. Whatever urine gets collected needs to be recycled. So every little bit of water we can sort of recycle needs to be recycled as well. The good thing about water is when we talk about radiation shielding, that you can put the water in the walls. So you can more or less build the habitats in a way that you can store the water in the walls, and that also then shields you from radiation to a certain extent. And the last but very important part for life support is the food production. We talked about this last time with the soil. In the moment, we have no plants that could grow on the Mars surface, so we need to grow food on Mars. We need to find a way to grow food in the habitats with hydroponic farms and aeroponics, or we need to bring enough food with us, and then also we need to preserve that food and we have to store that food. So these are all technical challenges that are not necessarily only a problem on Mars, but specifically on Mars are very important to tackle.
Well, with all those power-hungry life support systems, I think a very interesting question is the energy production.
Energy production and also management of energy is extremely important. Similar like on Earth, where we try to find ways to not pollute the environment in our case, so we find more and more sustainable solutions. On Mars, we need to find a solution first to make energy in the first place. Unfortunately, we have not big oil reserves on Mars. Probably not. I mean, we don't really know, but if there was never life on Mars, then it's unlikely that there's any oil, because obviously oil is old dinosaurs, pretty much. But yeah, so therefore we have to rely on solar power, nuclear power, and also battery systems. The problem with solar power on Mars is that Mars receives about 60% less sunlight than Earth. And we have lots of dust storms, which we discussed in the last episode. And these dust storms, they can last for months. And obviously, you don't want a solar panel outside and then covered in dust. With dust on the solar panel, you don't get any sunlight onto the solar panel, so you get no energy. So an alternative would be bringing nuclear power onto the Mars surface. But then nuclear power is obviously extremely difficult to build in general, although it's the one of the best solutions we do have. But in terms of transporting the material and transporting also the fissile material, which is very heavy, is expensive to bring to Mars. But I think in the long run, nuclear power might be the most reliable energy form we can bring. There are RTG batteries we could use for some stages, but in general we need to store a lot of energy. Also similar on Earth, where we have not really solved the battery saving system. We have lithium available, we have maybe sodium batteries available. On Mars, although on Earth it's not really a viable option to use hydrogen as an energy storage, on Mars that might be a viable option. Because we need to split hydrogen and oxygen anyway, so we end up having hydrogen in hydrogen storages, and we also need hydrogen for fuel. So therefore, that might be a viable option, but it comes again with its own technical challenges, because hydrogen is very volatile and also penetrates even steel. So therefore, you need to find a way to store it. And if you want to cool it down and liquefy it, then you have to put a lot of energy into the system in the first place. So it's not very easy. Energy and production and management comes with a lot of challenges, not just inherently for Mars. They are inherent for any energy and production system.
Well, let's talk about the communication challenges that we face, because I can imagine that communicating with Mars, it's a little bit more tricky than communicating here on Earth.
Yeah, it's not like you pick up the phone and you can get a call or do an Econauts episode from Canada to Australia, which also has already challenges, as you know. But on Mars, there are just the sheer distance, depending on the relative position of Mars to Earth. We have a one-way communication delay of between 4 to 24 minutes, which means two-way is you have to double that up. So imagine we would do a communication like this. I say something, wait for 24 minutes, then you hear it, You say something in response, then we wait for another 24 minutes, and then I can respond. So especially in, let's say you need an emergency evacuation protocols or something like very quick from Earth, depending where you are with Mars in the moment, you might have to wait almost an hour to get the response from Earth. And also the other problem is on Mars in the moment, we have here mobile phone towers everywhere. We have satellites already in orbit that enables us to communicate globally. On Mars, there's nothing. So we have to establish a local network on Mars in the first place. On top of the delay and on top of not having a system in place, we need also to discuss or we need to consider the data transmission. If you transmit data for these vast distances, you experience often data loss because of, there's a long distance, there might be something in between, there might be radiation, there might be solar storms and so on. There is a lot of data loss the further away you go from a location. And also if you consider an antenna, for example, an antenna is spreading the information in, even if you focus it a little bit, after that distance, a laser pointer, for example, which has a millimeter in diameter, would be hundreds of meters across. And that means you have to be very sensitive in your measurements as well to even be able to receive the information in the first place. So communication is not an easy task, and it is possible. I mean, we have the Mars rover on Mars, and we can control it. We also have Voyager 1 and 2 outside of our solar system, and we can still communicate to it. But again, if we have more and more people, we probably have also more data transfer in the first place, and therefore we have to tackle these challenges. And I think, in my eyes, the most important part is establishing a local network on Mars in the so that people on Mars can communicate with each other.
A local network on Mars makes sense, but the other thing we also have to consider is, of course, transportation and mobility.
Transportation also including the logistics. First of all, we are talking being on Mars. So the first thing is we need to get to Mars in the first place. So we need reliable rocket systems that can transport humans between Earth and Mars in a way that we reach there healthy. We can transport enough material with us. We can transport enough food with us. So these rocket systems we need are, we need to be able to rely on them. SpaceX with Super Heavy is making big strides, obviously. They are testing more and more until they can actually use it. They can refuel in our orbit, in Earth orbit, therefore bring enough fuel with them to, also use on Mars or have a reverse trip. But right now, we don't have a proven system to transport people reliably between Earth and Mars. Also, coming with the transportation and logistics in this case, it's not like ordering a pizza and then in 20 minutes you have the pizza or the pizza is free. It takes like a lot of effort to plan a mission, to plan a resupply, and then to send. It will take a couple of weeks and months before the supply will then arrive on Mars. So you have to be able to plan and predict for long times what you will need and when you need it. And also you need to be able to then to store it, as we mentioned before. And also on Mars, the Mars surface is very rugged and dusty. So if you want to traverse on the Mars surface, you need to be able to build rover systems like the Mars rover we already have there, but probably also better ones that can actually traverse in that environment. We have had the little Mars drone, so we had something flying on Mars, but although it might be easy on Earth to fly, we have a thicker atmosphere on Earth. On Mars, we have a very thin atmosphere, meaning that anything that flies has a bit of a harder time, which also, again, reflects back in the rockets. Landing and launching from Mars is also a bit harder, maybe a bit harder than landing and launching from Earth, because we have a thin atmosphere. We need to decelerate most of the time with the nozzle systems and the rocket systems itself, which means we need to decelerate, we need to use more fuel. So, these are just like a a bit of a spectrum. Obviously, there might be many more technical challenges, but I think that that's a nice nice summary of the technical challenges we face.
Well, we already talked about a lot of technical challenges today. I cannot wait for our next episode where we talk about more challenges. If you like this episode, please don't forget to leave a like and subscribe if you haven't already.
And if you don't want to miss any of our new episodes about Mars and about other things, hit that notification bell.
And I will see you next time. Bye-bye.
Bye.